All right, today we are going to begin chapter 7. I just want to review some simplifying radicals and operations with radicals, like multiplying and dividing with radicals. So, first, let's start off with simplifying radicals. Remember, we can break down a radical into a perfect square and what's left over, right? So, square root of 20 breaks down to the square root of 4 times the square root of 5. And the square root of 4 is 2, so the answer is 2 root 5. That is simplified in radical form. If I look at 75, I know that 25 is in there. That's a perfect square. So the square root of 75 breaks down into the square root of 25 times the square root of 3. The square root of 25 is 5. And then the square root of 3 just remains square root of 3. It does not simplify. Okay, then they get a little harder. I don't know if you know that there's a perfect square in 48. Remember, you can do that prime factorization, but I'll save that for 153. So 48, I know, is 16 times 3, and 16 is a perfect square. The square root of 16 is 4, and then it simplifies to 4 root 3. If we did a factor tree, I'll just really quickly refresh your memories if you forget, right? We look at 48. We want to do prime factorization, meaning we divide this number by prime numbers. I always start with the smallest primes, like 2, 3, 5. Those are my go-to prime numbers. So since this is even, I'm going to divide it by 2. I get 2 and 24. 24 breaks down to 2 and 12. 12 breaks down to 2 and 6. 6 breaks down to 2 and 3. Now, all of my ends for my prime factor tree are prime numbers, right? So I'm going to circle my pairs. So I have 1, 2, 2 pairs of 2s, and a spare 3. So that means for each pair, 1, 2 comes out front. So I have 2 pairs. That means 2 2s come out front, and they get multiplied together. And I leave that 3 inside the radical. This still reduces to 4 root 3. So it doesn't take that long to do a prime factorization if you don't know your perfect squares. All right, and then I look at 153 and I'm like, I can't look at that right away and be like, I know it has a perfect square in there, so I'm gonna do prime factorization. Okay, it's not even, so I'm not gonna use 2. I'm gonna try and see if 3 goes into 153, and it does, 51 times. Now, 51 is also not even. I'm going to go ahead and divide 51 by 3. And I get 17. 17 is a prime number, meaning the only factors are 17 and 1. There's no other factors of 17, so that stays. I do have a pair of 3's, however. So that means 1, 3 comes out front. And this spare 17 goes in the square, right? Or it stays in the radical. So square root of 153 simplifies to 3 root 17. All right, now let's talk about multiplying radicals. When you multiply radicals, you multiply like terms, right? So square root of 2 and square root of 6 are both square roots. So I'm going to just multiply those together. And 2 times 6 is 12. Square root of 12. Now the problem here is I need to reduce. This has to be in the most reduced radical form. So I know the square root of 12 breaks down into the square root of 4 times the square root of 3. And the square root of 4 is 2. And the square root of 3 does not simplify, so it stays inside the radical, like that. All right, in my second example, I have square root of 3 times the square root of 12. I multiply those together, and I get square root of 36. Well, that's nice because square root of 36 is a perfect square. That is just 6. No more radical. All right, here's where they get a little more complicated. So the numbers out front are not in the radical. They are like terms. I'm going to multiply 2 times 5. and that gives me 10. Then the numbers in the radical I'm going to multiply. Square root of 5 times the square root of 3 becomes the square root of 15. You always want to try to see if you can break down 15. 15 is 3 and 5. There's no pairs of numbers. There's no perfect squares in there. So it's just going to be 10 root 15. That's as simplified as it gets. All right, let's look at the fourth example. Here we're going to multiply the numbers out front again, right? 3 times 2 gives me 6. Then we multiply the radicals together. Root 2 times root 6 is root 12. All right, and if we look at our example up here at the top, we know that root 12 becomes 2 root 3. So I'll take it step by step, all right? First, let's just keep that 6 out front, and we'll break down root 12 into root 4 times root 3. All right, we still have that 6 out front. We know that the square root of 4 is 2, so that's going to get multiplied with the 6. And the root 3 is just going to remain inside the radical. And 6 times 2 is 12, so this reduces to 12 root 3. All right, not too bad, not too bad. Let's take a look at some more complicated multiplications of radicals, okay? Well, this one's not too bad, right? Because 4 times 2 is 8. And root 6 times root 3 is root 18. Well, I have to simplify root 18, so I'm going to keep my 8 out front, and I'm going to split up the square root of 18 into the square root of 9 times the square root of 2. Still keeping that 8 out front, the square root of 9 is 3, so that's going to get multiplied to the 8 now, and root 2 is just remaining root 2. And 8 times 3 is 24. Don't forget your root 2. And there it is. That's your answer in its most simplified form. All right, when you have an expression that is squared with a radical, I'm going to expand this first example, and then the next two, I'm going to just show you how I would do it if I were doing this assignment, okay? So when we square something, remember, that means we're multiplying that item, times itself, right? So now I know I'm squaring 3 root 6, so I'm going to take 3 root 6 times 3 root 6. Well, 3 times 3 is 9. And 6 times 6 is root 36. Well, we already know the square root of 36 is a perfect square, so keep that 9 out front. Square root of 36 is 6. Now 9 times 6 is 54. Boom. No more radicals, okay? So, the analogy I use, and it's kind of crazy, right? We're going to square this first number here, so that's going to give me 25. And then when I square the radical, it's like throwing a brick at that radical and just bust it out. Freeze that 7. So this is just going to be 25 times 7. No more radicals. 25 times 7 is 175. Done. Okay, I'm going to do it again. Here we go. I'm going to square the 2. That gives me 4. And when I square root 5, or square root of 5, I just free the 5 outside of the radical. I bust that radical up. So now this just becomes 4 times 5. And 4 times 5 is 20. Like if we look at this example, the second example here, right? I had square root of 6. Notice that in the end, I had 3 squared, which is 9, times 6. Okay, so that's what I'm doing here. I square that number out front that's not in the radical. That gives me 25 here in that example. And when I square radical 7, I just get 7. All right, let's look at dividing with radicals. We're getting crazy. All right, so here's the thing. When you see a radical in the denominator, you have to rationalize the denominator. So I know that sounds weird, and I'm not sure how much practice you guys had with this in algebra, but in order to rationalize the denominator, we have to get rid of that radical sign. So I'm going to multiply by 1, but in a really ugly way, right? So I just use that denominator, it's like square root of 5. So I'm going to multiply this whole quotient by square root of 5 over square root of 5. And again, while I'm doing this example, I'm going to show you all the steps, and then I will make it just a little bit simpler when I get down to the bottom here. All right, so 6 times root 5 is 6 root 5. That's okay. And now root 5 times root 5 is square root of 25. The square root of 25 is a perfect square, and that's the reason why I multiplied the quotient by root 5 over root 5, because I wanted to have just an integer in the denominator. So now I have 6 root 5 on the top over 5. Now be careful if you can simplify here. 6 over 5 does not simplify, so this is my final answer. All right, let's look at this second example. I have 6 over root 2. I have to get rid of this root 2 in the denominator. I cannot have square roots in the denominator, so I'm going to multiply by 1 in the way of root 2 over root 2. 6 times root 2 gives me 6 root 2. Root 2 times root 2 is root 4. What's the square root of 4? Well, just 2. So if you can see, when you multiply them by themselves, it is like squaring it. So it's like freeing that number from underneath the radical sign, and then there it is. It's beautiful. That denominator is rational. I love it. I'm finito. Or am I? Does 6 over 2 reduce? Well, you're right, it does. 6 over 2 reduces to 3. So now my final answer is 3 root 2. I guess I put my answer in a square a little too soon. Get rid of that. And we'll put it right here. That's my final answer. It must be reduced. All right, so now they're getting a little more funky, because I got radicals in the numerator as well, but I'm only worried about the denominator, okay? So whatever the radical in the denominator, that's what you're multiplying by. So now I'm going to multiply by root 3 over root 3. All right, when I multiply 2 root 6 times root 3, I'm only multiplying their roots together. Keep the 2. 6 times 3 is 18. So now I have 2 root 18. In the numerator, in the denominator, root 3 times root 3 is just 3. Okay, so here's where things get a little like, what? Gosh, math, I got to keep going because I have to simplify the square root of 18. So now I have 2 root 9. Well, you know that 18 breaks down into 9 times 2, and 9 is a perfect square, so that's what we're looking for, okay? The square root of 9 is 3. That gets multiplied to the 2, so now I have 2 times 3, radical 2 over 3. Simplify this a little bit more. 6 root 2 over 3. And we have one more thing to do. We have to reduce these whole numbers out front. 6 over 3 is 2. Don't forget your root 2. Sorry, it looks like a Z, but the pen's a little sticky. All right, so that was a little involved. I think this next example isn't as bad. Let's take a look here. I have root 5 over root 3. Remember, it's the denominator that we use to determine what we're going to multiply by, and we can't have radicals in the denominator. So we're going to multiply by root 3 over root 3 once again. Root 5 times root 3 is root 15, square root of 15. And square root of 3 times square root of 3 is just 3. Okay, so 15 breaks down to 5 and 3. Well, there's no pairs, there's no perfect square, so there's no sense in breaking it down. It doesn't simplify. Do not try to simplify within. 3 is a whole number, and root 15 is a radical. So they are not like terms. You cannot go in here and simplify that. This is it. This is as far as it goes. So that's not too bad. All right, let's look at one more example. All right, here we go. Now I have 9 root 5 over root 3. Well, what am I going to do? I'm going to rationalize the denominator. How am I going to do that? I'm going to multiply by 1 in a funky way. It's going to look like this, right? root 3 over root 3. Right, when we multiply by 1, we're just giving this a makeover so that we can manipulate it to do what we need it to do, right? I need to rationalize the denominator. So remember, the 9 stays out front. Root 5 times root 3 is root 15. Remember, root 3 times root 3 is just 3. We free the number. I can reduce these numbers because they are whole numbers, right? 9 over 3 reduces to 3. And don't forget your root 15. And that is my final answer. All right, well, hopefully this helped you so you can do the worksheet for today and have an awesome day. And I'll see you tomorrow.